this video we will continue to this number 3 project called window stopper. It's like this one. Here is the link of the book and also the repository we have done. And let's do this one. So if you come to the repository, in the right, there's a master OpenSCAD, and then till the last video, I have put those snapshots, the models here, and I also download the finished model from here. So for this window stopper, from the bottom you have this the finished model or complete model. But what we will do is we will make this model step by step. So if at your home you have this similar model, then you have a way to have more understanding about this. What we will learn from this model build is we will learn our generative for loop to generate our list, and also we will make some more way to convert from this 2D the shape polygon to 3D. So within our model, we call this a module window stopper, but we will have one window, a submodule, one stopper case, and also a real stopper. So let me close this one and create a new file and save files here. Window stopper. Let's do this 01. So it's empty. And for this one, we will have our purpose of this program or this model. So we will build our window stopper with rotating wedge. All sides we should be claimed is in the millimeter. And on this first part, we just make the basic one stopper module. And within this stopper module, we will have some perimeter. We use this one. Also the comments. So these will be put in here. So we will have this perimeter line by line, as we did earlier. And then from here we make our FN. Let's start from smaller so that you get the model running fast for this rendering, but later on we can make that bigger. So module windows, that is first one. Module stopper case, that's the second one. Module stopper, that's the third one. And within this the big module, so we will call those, and we try to call without any perimeter. So stopper case, then stopper. After this, finally we will call this complete module with a certain perimeter. So those are also where we need to add some perimeter. Then with those we are making our program like this. So that is our the structure of our program. With this one, let's save and save as to next model. So we go to the 02 with actual the doing something. So we in last one we have 3 sub module. We will do this one by one. So we're starting from this some perimeter. So if we want to build the window, then we need to know the window's this thickness and the window sill distance. So that is our first perimeters to build. So window thickness. Let's add those default value later on. Thickness of window frame. That's 1. Second, window sill disk distance. Let's use this comma because we will very easily to forget about that to generate error when we have another the perimeter you want to add. So if I have these 2 perimeter, then we will use that. So that is no need to call those perimeter first, but we will call that later. So we gave the window a color. So we use this color name. So light sky blue. That is 1. And then we start to build this cube. So this cube is on X is 100, window thickness, and Z is just 0.1 the height. So let's give this thickness, like say I want this 10. And we are doing this one, so no thickness, it's just our frame. So and we will do this the translate. So translate to x minus the x now is this direction. So x go to the minus 20, and then make this half in y. So they will come to this in the middle, and then go this to z is go to our distance. So distance, let's go to 20 first. So we will see translate minus 20 minus window thickness divided by 2 window sill distance. Then we will have this done. So that is coming like this way. So now y is go to the half, x back to 20. So let's see what we will do is we will make our frame so that later on we will see how this will be used to do this stopper. So that is our second one. Let's save and go to the third one. So we have added perimeter window thickness, window sill distance to our module. They describe thickness of the window. So we're starting to have some just the basic perimeter in our module, and the distance of the low edge of the window to the window sill. So in the submodule window, we only describe this low edge with our 0.1. We set the width of the cube to an arbitrary 100. So that is 10 centimeter. using this translation, we bring the cube to the height, window sill distance, and center it over the x. So this is not the center over x. So here is over y. So that is the thing is we need to pay attention. So that you remember here is over y. So I will try to mention this after the video to the author. To visually set off our object from rest of the geometry, we give a nice shade of the blue. So, but you don't see the blue here. You need to cover that. The light sky. So let me see. Yeah, I should not use this. So if you have this semicolon, then color is the self content as our this statement, so they are not take effective. So I also need to open this 20, so delete this semicolon. So then you have this blue. Let me save this and close, and we continue with this 03. The geometry described on the holder is a bit more. Then we can access perimeter of the parent module window stopper directly and do not have to pass them with using all local printer perimeter. But let's put this first, just because we want to make some drawing. And then we're starting to have this second, the part is a stopper case. So we have this anchor cell, and we need to make some more perimeter. So window sill adjustment, putting that to 0. Let's see, adjustment for window sill distance. So don't be afraid of the long the model file. So we do this as module sentence by line and sub-module by sub-module. So you will see that gradually you have something on hand. So we define this stopper width. Then that is the width of the stopper. So we need that perimeter, and also we gave our material thickness. This stopper thickness, we give that as 5. So window don't need so maybe we give this also 5. Let's see, window is let's say keep that 10, and this not go so high. And then material thickness of the stopper, that is 1. And then we have a window overlap. Give this 7. I don't have this meaning understood now, but let's see what was the effect of those overlap of stopper and the window. And Excel DM. You notice I modify this semicolon, so that is a typo error. So whenever you make your drawing, keep examine your code. So Excel diameter. Here is we will have our circle or cylinder, so we need this kind of the clearance and the diameter 0.5. So we finish most of these perimeters. The definition first bushing. Then we will go to more the calculation. So first is we have this anchor cell diameter. within the module, we will define the height. So that height has some the relationship with the existing the parameters. So material thickness, so that is the windows stoppers thickness, and plus window sill dist minus material thickness divided by 2. So that with this formula, we built the relationship from this the window stoppers material thickness to your window this window sill distance. So when we start to build this windows sill distance, then we can start to impact our material thickness. And then we're starting to have our second module that's defined, so stopper case. So let's see case size. You have some parameters. So these key sizes are the vector. So X is stopper width. Y is window thickness plus material thickness. I put this mathematical calculation after the perimeter. So third is the window sill distance plus window overlap. So we got this as our first definition, like our case size, and then we have this is 1, and we translate some somewhere, and we see we have a difference, and difference is starting from cube as the base, and minus 1 cube, and minus 1 cylinder, and the third cube. And then we have this the last cube part. So we do this one by one. So first, let's draw this one. So let's see what this means. So I will just copy this, so save your time. So cube axial bushing is this. I should have this one defined first. Is this diameter plus this clearance. Clearance is the transverse bushing. So let's draw this. So we have one of this cube. And before that is let's have our base cube. This cube is we have our case size already defined. So we have this big one, and we need to the difference that one. So we have starting to have those. That is the first and the second. And let me make this one. So let's press 6. Then you have the finished one. So now you see we have a big cube and we minus our small cube. But this small cube is we need to have our translating. So we don't minus that from the origin. So we translate this and you give our tab here. You see, it's translate to the middle. So that is this first the remove. Then let's have the second part. We have our cylinder. Let's see. So we have this by default is here. And then what we need to do is let's back to our this part. So the cylinder should be here. So we need to move that first, rotate, and then shift that to bottom of this the cut. And the third one is this horizontal cube. So we have 3 knives. So first, let's rotate. Rotate now is on the Z. We need to make that go to the Y. So that means they need to rotate per X. And no matter X, I think we need to go to this direction. So that is minus Y, X. If you go to the positive 90, it's go to this direction. So, for example, let's have a look. So, but actually, what this means, let's make our highlight. So now you go to this. So we need to have this -1, so they come to here and make the cut. So, but we will not reading the cut from here. So let's practice this. It's cut from here. We want the cut from here. So that is then we need to make our translate. So you can examine these parameters or calculation, but the purpose is we translate this to the middle and under this the cube. So it's here. So I just keep this 10 for phase number. Later on, we can increase that to a bigger one. But now let's keep that performance is faster enough. And then we have the third one. Third one is another cube. So this cube is also our big one. You can see this one, but we want this not cut the most the front of that. They need to shift in the middle. Then they cut from the this half. And also they need to go a little higher so that they don't cut from the bottom. So that is this translate means. So let's add that and make the tab. So now you can see it's perfect. We have our number 3. We get quite good shape on this window stopper, and also this already in the finished one. And then let's save and go to the number 4. Yeah. So I actually sorry, is let's keep using this number 3. We still have another the cube I didn't draw. So let's open this. So what's the outside? If you highlight here, you can see the these curly braces is here. And then what we will go to is we have another cube. Let's see what's this drawing. So window. So we don't have those cube coming. Let me highlight this. It's in the middle, I believe. Cube size X. Cube size X is stopper width. Cube size Y is this one. All of them we have the parts, so Y is not coming. Its difference is here. Because we don't have this definition. So stopper width. So let's see stopper width 10, window seek plus all this. So we have the stopper width. Stopper width is here, 30. Window thickness, material thickness. Window thickness is 0.10 plus material thickness 2 times 5, so this is 20. And the window sill this is 10 plus overlap is 17. So we should have this drawing. So let's echo. So now you can do this is case size. So we have this 30, 20, 17. So we should have that, and we use this case size X, case size Y, window sill adjustment. Window sill adjustment is 0. So here is 0. So that is the case. So there's invisible. So now it's like this one. But we put that as 0, so that means you don't actually draw this cube. So that is the thing is we need to further in the later model you will see what's the reason we and how we can make this windows adjust. So let's translate this with some actual value. So this is actually is move to the bottom. So that is the part. So this is the number 3. So but if we go to this based on the sample, so Windows adjust, we put that as 0, and this is invisible. So I just put 1. So at least we see we have our model here. And let's use this to make this a number 4. So we stop here, and the next video we go to the following parts of this number 3. Thank you.